Okay, remember. Okay, do I have all of you? Okay, now we are going to talk about Newtonian physics, which is something we can see. Okay, it's basically a ball drops down. Remember, we can measure it. Okay, at what time will the ball drop from the resting place? So this will be our used as the distance. At any particular time of the distance, we write as function, right? The distance as a function of time. And we can somehow record it. Zero. This is the time. This is the distance. Time 0 gets 0 meter. This is a meter. And 1 second gets to 4.9. And 2 seconds, 19.6. 3 seconds, 44.1. Now we're going to find, let's say we do 5 data points. Right? So each one is a point in the Cartesian graph system. So we go down this one. We go down this one. And if we plot it, if we plot this is T, this is S. So 1 second, 2 seconds, 3 seconds, 4 seconds. We'll end up with something. We end up like something like this, okay? And we can find that if we want to do the curve fitting, we can fit it with quadratic function. S equal to S times T is 4.9 T squared. Okay? Well, we're good so far. So now we're going to find what is our instantaneous speed at t equals to 2 seconds. So how do we find instantaneous speed?
You have to first find average speed.
Find the average speed. So that means we need 2 points, right? What is our first point?
1.
At 2 seconds,
19.
19.6. Then how about our second data point? How do we do second data point?
3.
Remember, we're going to play the moving the second points to the first.
1, which is 4.9.
What's that?
Be like 2 plus h.
2 plus h. Right? Are we good so far? Questions?
Why is it
Right?
plus h?
Are we good? Okay, pay attention.
Why is it plus h?
This is our first point.
Yeah.
Our second point is h away. So
Oh,
2 plus h. Remember what we did last time.
Why do we not choose 3?
Well, we are going to put a variable because we're going to move it.
Okay.
3 is a fixed number. We'll put it somewhere, okay?
Okay.
So our h is a variable, and h is going. We're going to push h to 0. Remember that. We good on that one?
I have a question.
Yes.
Why is 3.2? Does it have to be
It doesn't matter. We say we start at 2. We're trying to find the instantaneous velocity at t equals 2 seconds, just as an example. Okay? We good on this one? So what will be our y here? Huh? Don't forget this. This is our function.
4.9.
4.9, 2 plus h squared, right? Okay, so what is our average speed? Average speed is the difference in distance over the difference in time, right? So what is our difference in time? We're from 2 seconds to 2 plus h seconds. H. What is our distance? 4.9, 2 plus h squared, right? Minus 19.6, right? We're good here so far? So now we work it out. 4.9 times 2 is 4 plus 4h plus h squared minus 19.6. And what is 4.9 times 4? You can guess it. What's 4.9 times 4? First one.
It's a little less than 20.
Huh? Which will be exactly this, right?
19.6.
Right? 19.6h plus 4.9h. Remember, something could be cancelled out. Is this guy. That. Right? And then we have something h as a common factor because we're going to cancel out h. Move h out. 19.6 plus 4.9h over h. Now h and h cancel. Remember, our h is not 0. So we get 19.6, 4.9h. Now, as h approaches 0, that's how we do it. Push h towards 0. What is our average velocity?
19.
Which becomes what? Instantaneous.
Right, yeah.
Will become instantaneous speed, right?
Yeah.
So let's write as this. At time of t2, that gave us 19.6 meter per second. Okay, so that is the instance we have time at 2 seconds. What happens if we say, okay, can we find the instantaneous velocity everywhere from 0 to whatever time? How do we do that? So how do we find, how do we pick our first point? Remember our function. S of t is 4.9 t squared. So now we're going to say we want to find instantaneous velocity at any time, not just t equal 2 seconds. So which means, where do we pick our first time instant? At t. Okay, t, what is our distance? At 4.9 t squared, right? Right? First point. Second point is going to be t plus h, 4.9 t plus h squared, that, right? Good? So what's our average speed? Is what?
H on the bottom.
H on the bottom, on top, 4.9 t plus h squared, right? Minus 4.9 t squared. So can we move 4.9 out in front? So we can 4.9. What's left here is what? T plus h squared minus t squared. H, right? Good? Any question? Follow me? Yes? Make sure you follow me, okay? Otherwise, that's it. You cannot go any further. Okay. Without understanding this, the calculus doesn't make sense to you, okay? So you got to understand this. What?
Well, you like to stay right there.
Okay. So, what is this minus that? T plus h squared, what? T squared plus 2th, right? Minus plus h squared minus t squared, right? We good? And t squared and t squared cancel. So what we have here is what? 4.9 h here. This is a 2th plus h squared. Then we can move h out. That's 4.9 h here. 2t plus h and h. H and cancel. We got 2 times 4.9 times 2t plus 4.9 times h. Okay, right? You got? So as h, we push h to 0, and our instantaneous velocity at time t is what?
9.8.
4.9 times 2. What's that? 9.8 t. So that meter per second. Okay, we good?
Yes, it would work.
So it's just gravity.
This getting to the instantaneous velocity. Okay, now what is our acceleration? Acceleration is what?
Velocity over time.
Be more precise. Acceleration is the difference in velocity over difference in time. Right? It's not just velocity over time. It's a difference. Okay? But this is average acceleration per bar over. So how do we find instantaneous acceleration?
Yes.
How do we find instantaneous acceleration?
Use the secant.
Yep, same thing. 2 points, right? Right? So what is our first point? It's t, right?
Yes.
What is our velocity at this point?
Oh, you just do it again. Oh.
9.8.
9.8.
That's crazy.
Okay, second point,
T.
t plus h. Right? Right? We good?
Dr. Chi, we should have a paper airplane contest when we talk about like.
Oh, dude, we did that in the
All right.
3D printing camp.
Okay, come back here. Right? Hey, follow me. Okay, you got to follow me here. So, now we're going to find the instantaneous acceleration, okay?
The second one's squared.
What's that?
The t plus h is squared.
Delta v over delta t is? What's delta t?
Delta?
Delta t, sorry. What's delta t?
Is the second one not 9.8 t plus h squared?
No, because we're talking about velocity. Yeah, we're using this function now. Because acceleration is based on the velocity, right? We know the velocity function. We good? Now, what do we have?
Wait, but
Bottom is h still, right? Time to time distance, right? Top,
that was last.
top is what? 9.8. Are you guys with me? Are you guys with me? Still? Okay. Minus 9.8 t. What we have here? Move 9.8 out. We got t plus h minus t, h, and 9.8 h over h. And that got canceled. We got 9.8. So the instantaneous velocity is 9.8 for a free fall object,
Oh, hey, that's
which is a
gravity.
constant. That is the standard gravitation. That's
Crazy how that.
You just got the gravity.
okay. And see here.
You just got the gravity.
Okay, notice. Notice. Guys, pay attention here, okay? We start with a function, which is the distance as a function of time, st. Then, finding its slope, right? finding slope function, we find the velocity. And we write as this, is ds over dt, that's derivative. Right? We good here? Are we good here? And our acceleration as a function of t is dv over dt. All those, we take derivative. Remember, derivative just means we find the slope, right? These things, whatever we have here, you see those t plus h minus that, right? That's how we find the slope, right?
Right.
So that's called derivative. And notice here, we can measure s of t. Can we measure v of t? We cannot direct measure it. It's based on this function. So this function actually is derived from this function. And acceleration is derived from the velocity function. So that is called derivative. It's derived. We cannot get this directly. You have to go from whatever function we can measure. Right? We good? So that basically is how Newton invented his calculus. But he actually was using different notations. I'm using the Leibniz notation, which is much clearer. But he invented it. And because his invention, he came up with the laws of the physics, which is the first law is what? It's inertia, right? Second?
Momentum. Equal and opposite force.
No.
Oh, that's third. Sorry.
Second is
It's
F equal to
mass times acceleration.
mass times acceleration, right? And which he writes, because of gravity, you write as that, right? We good on that one?
What?
If it's gravitational, we write m times g.
But
if it's not, if it's just any object, it's F equals ma, mass times acceleration.
isn't it something like 1.5 mg squared or something like that?
That's when you find the distance.
Oh, distance equals 1/2. Okay, no object. I'm fine.
So that is actually the other way of calculus. It's called integral calculus, which is second half.
Which is better?
You need both.
You need both? Can you combine them?
Oh, you find that. Like you need both.
My brakes and my motor are right here while I'm